Hello class, welcome to lesson 2.2. Today the topic is on functions. So before I begin to explain what a function is, I want to start with a similar concept. It's called a relation. Okay, now what is a relation? Well, a relation is a correspondence between a set, which we will call a domain, and another set, which we will call a range. Okay, and I'll add another condition such that each member of the domain corresponds to one or more, so it could be 2, 3 members of the range. So I know that's a lot of words. I will explain what I mean by drawing a few pictures. But basically we have one set, we have another set, and we're pairing things together. So let me draw a picture. Say we have a set of things in this circle. Say we have a smiley face, a medium face, and a frowny face here. Let's call this set our domain. And we want to correspond these to numbers, so we want to number these emojis here. Or we want to correspond a number to each one of these emojis. Now, we could have the smiley face be corresponding to the number 1, so we have a correspondence here of smiley face and number 1. So instead of writing a smiley face, we could write the number 1 in it, right? The smiley face corresponds to the number 1. But notice I said the correspondence here is 1 or more, so we could also have the smiley face correspond to number 2. That's allowed for a relation, right? So the smiley face is related to number 1 and it's related to number 2. And then let's have the medium face be related to number 2 as well. The frowny face will be related to number 3. So this is our relationship here. The smiley face corresponds to 1, and it also corresponds to 2. The medium face corresponds to 2. The frowny face corresponds to 3. All right, so that's a picture. All we're doing is we're pairing things in our domain and our range. Right, this is the domain is the set of emojis. Our range is a set of numbers. Now there's a few other symbols we could use. We could put this as what is called ordered pairs, or we could do smiley face 1, smiley face 2, medium face 2, frowny face 3. Okay, this means the same thing as my picture. Smiley face is related to number 1. Smiley face is also related to number 2. Medium face related to 2. Frowny face is related to 3. Right, so it's just a different symbol to write the same thing. This is representing the relation with symbols in a picture. Okay, so pretty easy concept. I'm sure you've encountered real life examples of relations before. There is another way to represent an equation. Right, so this was a picture to represent an equation. This was a set to represent an equation. This was a set to represent a relation. We could also use an equation to represent a relation. So for example, I'll just give you an equation for a circle. This is an equation for a circle. It is also a relation. Why is it a relation? Well, we have a domain and we have a range, right? We could, let me draw a picture of this circle. So here's the x-axis, here's the y. So there's the number 1. This is the graph of the circle. Now notice, say, I don't know, when x is 1/2, right? When x is 1/2, well, that corresponds to this y value, let me call it y1, and this y value, y2. Right, so for something in our domain, it's related to two numbers in our range, right? Or this input is related to these two outputs. And that's okay with relationships. You can have something in your domain and it's related to two things in the range. As long as it's related to one or more things, it counts as a relation. So a circle is an example of a relation, because for any of these x values that we consider, there's going to be two corresponding y values. So if we consider this x value, for example, it will correspond to these two y values. Okay, so that's the three ways we can represent relations. We could draw a map like this, we could draw a set, or we could draw an equation and it represents a relationship or a relation. Okay, now that we have this idea of relation understood, we are ready to introduce a function. And a function is just a special type of relation. So let me define a function here. Alright, so a function is a relation, but we add one extra condition. So the condition is such that for each member of the domain, there corresponds one and only one. And let me do only one member of the range. Right, so with functions, we have a set here, which is the domain. We have a set here, which is the range. Right, so if we, again, have 3 emojis in our domain and we have 3 numbers in our range, for this to be a function, we could only map each member in the domain to one thing in the range, right? If I were to do this, it's no longer a function, right? If this corresponds to more than one, then it's no longer a function. It's just a relation, right? So that is the difference between functions and relations. Function is just a special type of relation where we're only allowed to match things in this way, where for each member of the domain there is one and only one member in the range. Now it can get a little tricky. Let me draw another picture of a function here. So let's look at this. The top one was a function. Now let's consider this bottom one. Is this a function? Well, yeah, because this corresponds to only one thing, this corresponds to only one thing, and that corresponds to only one thing. It's okay that they all correspond to the same thing. The only condition that we are requesting is that each thing in the domain is related to exactly one thing. So the only time something fails to be a function is when we have the following picture. I don't know, let's do a square, a triangle, and a circle. We'll connect it to 3, 4, 5. So say, for example, the square is related to the 3, the square is also related to the 2, triangle is related to 4, circle is related to 4. The reason this fails to be a function is because the square is related, or it's corresponding to more than one thing in the range. So not a function. And think about the word function. Say you were operating a machine and the machine had 3 buttons, like say you have a machine and the machine had 3 buttons, a circle button, a triangle button, and a square button. And each of these buttons has a function, right? Like, I don't know, let's pretend this is a video game machine or something. So like, this is the controller to the video game, and these are the buttons on the controller, and each control in the video game corresponds to a different thing the video game can do. So if you click, let's say you click the circle and that moves up, you click the triangle, it moves to the left, you click the square, you move down. That's a function. But your video game would not be functioning correctly if you click the circle, you move up, then you click the circle again, and all of a sudden it did a different thing. You would think that your video game was broken, right? If the circle was related to this, but then when you click it, it's also related to something else, then it's not a function, it's a relation, right? So when you have a machine, you want it to function, you just want everything in the input to correspond to only one thing in the output, like this. Then it would be a function. Okay, let's look at a few more examples. Let's use some different symbols. Here I was drawing pictures to represent functions, but let's look at some other ways to write functions or relations. So let's ask ourselves, is the following a function or just a relation? So we have 13(7). We have 16(-1). We have 47. We have 13(0). And we have 60(0). Right, so all of these are the domain numbers. All of these are the range numbers, if you recall, right? So I'll write that down. Okay, so first let's notice that the domain is the 13, the 16, the 40, the 13, and the 60. The range is the number 7, the number -1, the number 7 again, which we don't have to write it twice. That is a little redundant. We only need to write it once. The number 0, and the number 0 again, but no need to write it twice. Right, so the domain are all these numbers. The range are all these. You could think about it like points on the xy plane if you want. This is just a list of points on the xy plane. That's perfectly fine way to think about it. So our domain are these set of x values. The range would be the set of y values here. So here's our domain. Oh, and I wrote 13 twice, which it's okay. It's just a little bit redundant. Might as well just write it once to make our list a little easier to look at here. Okay, now, is this a function? Well, no. Not a function. Why is it not a function? Look here, we have a 13 in our domain, and it corresponds to the number 7. So 13 is related to 7. Now a function, only a domain member can be related to exactly one range thing, but 13 is also related to 0 in this set. So we have the element in our domain 13, and it's related to two things in the range, and therefore it's not a function. When we input a 13, it will spit out a 7, or it will spit out a 0. It's related to two things in the range, and that's no good. If we look at the definition of a function, everything in the domain is related to exactly one and only one thing in the range. And so this is not a function. It is a relation, but not a function. Right? It's perfectly fine to call this a relation, right? These numbers are related, these numbers are related, these are related, right? It's just a set of numbers that are related. But it fails the condition to be a function because 13 is related to two things in the range. Okay, let's look at another example now where we will use an equation to represent a function. Let's see, maybe before I talk about equations, I'll maybe talk about the graphs of equations first, and then we will use equations as functions after we get a little bit of graphical intuition here. So I'll give you a function here. Here's the function. Now I may be introducing a new symbol here. F of x equals x squared. And a new function here, f of x is square root of x. Now what does this mean here on the left-hand side? It's f of x. It's not f times x. It's just a new symbol where what we mean by this is we have, well, these are functions, but I haven't explained why they're functions yet, but these are functions where we plug in an x. So that's what we mean by f parentheses x. We mean function f and we plug in values x. Okay, so the formula is x squared here, and then we have another one, square root x. And I'm just going to give you what the graphs look like. Graph of x squared looks like this. It goes through the point 0, 0. Graph of square root x looks like that. Okay. So now that you have the graphs, you can sort of see that these are functions, because let's take the x values to be the domain, the y values to be the range. Right, so take x values on the graph to be the domain, and the y values on the graph to be the range. Right, if we do that, then we can see that f of x is a function in both of these pictures I drew, right? If we consider any x value on the graph, there corresponds 1 and exactly 1 y value. Right, so no matter what x value you pick, there's only one corresponding y value. Right, if we were to pick an x value here, for example, there's no y value, but there's also no x value on the graph over here, right? So that's the domain for this function is just all the numbers greater than or equal to 0. This one, the domain is all numbers, right? All numbers. So over here on the left graph, no matter what number you pick, there corresponds only one y number. Right, and that's why these are functions. So what we've just noticed is a way to figure out if a graph is a function or not. It's called the vertical line test. Right, so I'll draw a bunch of vertical lines through these graphs. The vertical line test is the following. It says if you draw vertical lines through your graph, right? Or let me reword this. If any vertical line you draw through your graph only touches the graph once, then the graph is a function. Okay, so I know that's a lot of words, but let's look at these vertical lines I drew through these graphs. So notice any vertical line I drew, it only touched the graph once. Because that happened, we can conclude the graph is a function, right? So no matter what the vertical line is through the graph, they're only touching the graph once, and therefore those graphs are functions. So let's go back to the circle here. Remember, we were talking about a circle earlier. Notice if we draw a vertical line through a circle, right, we could find a vertical line that touches the graph more than once. So in this example here, we notice that a circle fails the vertical line test. So a circle is not a function. It is a relation, but not a function. Right, we mentioned earlier that a circle was a relation, but it's not a function because for this value in our domain, this x value, there corresponds more than one value in the range. It's not a function. It failed the vertical line test. Okay? Okay, so now that we know how to tell if if graphs are functions or not, let's start investigating some functions or some relations. Let's investigate some relations and try and find out if they are functions or not. Okay, well, I'll give you an example. Let's consider this formula here. F of x is x squared plus y. Or, that's a little too hard, and we don't want two variables here. Let's do, f of x is x minus 1 over 2. Okay, now if you were to graph x minus 1 over 2, you'd notice it passes the vertical line test. So this is in fact a function. So we have a formula representing a function here. But the nice thing about this notation, about these symbols to represent a function, is that we can plug numbers into this. Right? We could plug in, say, the number 0. We could plug in the number 1. Right? We could plug in numbers that are in the domain to this. Right? So how do we do that? Well, recall what I meant by f of 0. That just means you plug in a 0 to the x. F of 1 means you plug in a 1 for x. F of 2, that means you plug in a 2 for x. Right, so f of 0 is 0 minus 1 over 2, negative 1/2. F of 1 is 1 minus 1 over 2. 0 divided by 2, that's 0. F of 2, 2 minus 1 over 2 is 1/2, right? So 0. So the number here on the left-hand side corresponds to the number we are plugging in on the right-hand side. And the reason this is a function is because anything in the domain, right, any number we plug in, it will be related to exactly one number, and if you were to graph it, you would see the graph would look roughly like this. I don't know, something like this, right? It's a rough, it'd be a straight line. Right, so no matter what x value you plug in, there's only going to correspond one y value. So this is in fact a function. But you don't necessarily have to graph it just to see that it's a function. You could just by looking at this, you know that no matter what you plug in here, it's only going to spit out one number. There's no way you could plug in a number for x and it will somehow spit out two numbers. That would be crazy, right? There are formulas where that can happen, but in this particular formula, no way. Another question you may be asking yourselves is, how do you find the domain if you are not given a graph? So here I just gave you a formula. I did not give you the graph. So how do we know the domain if we are not given the domain? We just are given a formula. Well, in this case, the domain of the function f is the set of x values we are allowed to plug in. To the formula. So for this particular example, when f of x was x minus 1 divided by 2, we can plug anything into this and nothing bad will happen. So the domain is all real numbers, or we sometimes write it like this, minus infinity to infinity, or all real numbers. This symbol might be a little confusing. We will learn about what this means in a later lesson, so don't get too hung up on this. It's called an interval, but that's a topic for a later lesson. It's just you possibly may encounter this in your homework, but don't get too hung up on it now. I don't want to talk about it yet. Just the point here is we could plug in anything we want for x and nothing crazy will happen, right? So what are some examples of when we are not allowed to plug something in? Well, let's consider a function. Let's consider a function like this. Yeah, let's start out easy. Let's do 1 divided by x. Right, this is a function. Notice we could plug some numbers in, right? We could plug in the number 1, and we get 1 divided by 1. That just equals 1, right? We could plug in a 2. But what if we tried to plug in a 0, right? We can't. 1 divided by 0 is not allowed. So that's one of the rules we need to remember in this class, is we cannot divide by 0. Division by 0 is not defined, right? That makes no sense mathematically, so there's no definition for it. We don't define this because it's nonsense, right? Dividing by a 0. 1 out of 0. Right, so the domain for this function would be all of the numbers we're allowed to plug in. Well, we could plug in anything except 0 here, so for the domain of f of x equals 1 over x is all numbers except except 0. Right. Okay, or another, put differently in different words, f of 0 does not exist. Okay, there's one more rule I want to talk about. So first rule is we cannot divide by 0, right? So if we encounter things like this, we are not allowed to plug in a 0. Let me talk about another rule. Now let's consider another function here. Let's consider, I don't have to use an f, I could use any letter. Let's do g of x as square root of x minus 1. Let's plug in some numbers here. If we plug in 1, is that okay? 1 minus 1, square root of 0. Okay, that's fine. That's 0. If we plug in 10, square root of 10 minus 1, square root of 9. Okay, that's fine. That's 3. Let's plug in the number, I don't know, negative 2. Negative 2 minus 1. Now, what do we do here? We have a negative number inside of a square root. And for this class, when we're dealing with functions, we want positive numbers under the square root. Now, if you get a little more advanced into mathematics, you will learn how to deal with a negative inside of a square root. But for this class, no, we don't want to deal with that. So the next rule is we want numbers greater than or equal to 0 in a square root, under a square root in a square root. Okay, that's when we're dealing with functions here. So the next rule when we're dealing with functions is we want the numbers under the square root to be greater than or equal to 0. So for example, if g of x is square root of x minus 1, we want the thing inside of the square root to be greater than or equal to 0. Now, this is the condition we want. Let me write it a little more simple. If I were to add the 1 to the other side, we want x to be greater than 1. Right? I just added 1 to both sides of this inequality here. Right, so the two rules when you're dealing with functions, I mean there's more rules, but we will learn about them later. When we're dealing with functions in this class, we cannot plug things in that would make the bottom 0, and we cannot plug things in that would make inside of a square root negative. So that is the two rules you should keep in mind for this section when you are dealing with functions, right? The two restrictions we will request. Okay, now what else do I want to talk about? Let's give you a formula here and a graph. So let's say f of x is x cubed. There's the formula. I'll also give you a graph. So we haven't really learned how to graph this. I'm just going to show you what the graph looks like, so you can connect the two concepts of a formula and a graph, right? So this is the formula representation of a function. This is the graph representation of the same function. Now, if we wish to find, say, f of 1, we could either plug in 1, and get 1. If we look at the graph, when x is 1, y is also 1. 1, 1. So this is how these are related. 2, we get 2 cubed, we get 8. So if you plug in a 2, you get an 8. 2, 8. And so on. I'm just demonstrating how you could represent a function, the formula or a graph here. And one other type of function you may see in your homework is an absolute value. So let's consider this function here. Let's say g of x is the absolute value of x plus 3. Now, if you have not encountered an absolute value, it's what these bars represent. An absolute value is it's a type of function that only spits out positive or 0, positive numbers or a 0. So I'll just plug in some numbers to demonstrate what an absolute value is. Let's say we plug in 2, then we do 2 plus 3. Okay, that's absolute value of 5. Now, since 5 is positive, the absolute value of 5 is positive. Okay, that's not too hard. Let's plug in a number like negative 7. Then we do negative 7 plus 3. So we have negative 4 inside of the absolute values. Now, if you have a negative number inside of these absolute values, the absolute value is a function that just forces it to be positive. Simple as that. So you'll encounter something like that in the homework. Okay, and then we want to know, what is the domain? Well, the domain, recall, is just all the numbers you are allowed to plug in. And the two rules I talked about were we don't want to divide by 0 and we don't want inside of a square root to be negative. But those two rules have nothing to do with this, right? No matter what you plug in here, you're not going to break those two rules. So the domain is all real numbers. Okay, and I will end the lesson here. So a quick review. What I talked about was I introduced what a relation was, and that's when we have a relationship like this where it's okay for something in the range to be related to one or more things in, or excuse me, it's okay for something in the domain to be related to one or more things in the range, like this picture. And then we found a special type of relation where everything in the domain is related to only one thing in the range. Okay, and then we could write a function as a list of xy coordinates. We could draw a map like these, or we could use formulas and graphs to describe functions. Now, if something fails the vertical line test, it is not a function. When it passes the vertical line test, it is a function. And we use this symbol f of x to describe relations and functions, and that just means you're plugging in x's to the equation. So f of 0, you plug in a 0, f of 1, plug in a 1, and so on. And when we're looking at domains of formulas, we need to keep in mind the rule that the bottom can never equal 0, and we want to force the inside of a square root to be greater than or equal to 0. And then I just gave you a special type of function, the absolute value. I showed you how to plug into the absolute value function, and there's no restriction on the domain for that one. You can plug anything into the absolute value function. Okay, that's all I have for today. Thank you for watching.